Okay, so guys, today we're doing 7.4. We're talking about slope. What I'd like you to do is, as a warm-up for yourselves, I'd like you to go ahead and graph the following linear equation using the intercepts. Want to make sure that you ask yourself, how do I know it's linear? Recognize what the x and y intercepts are, and then create a table of values like we did in class. Now I'm going to be checking this tomorrow in class, okay? But today we're going to be taking this a little bit further, and we're going to be talking about slope. So with your note sheets that you have, I want to remind you some of the things that we've already talked about slope. Slope of a line is like the slope of a hill, and you should be writing this down where it says slope. It's really like how much I change from one place to another. So if I look at my little guy, my little bear, he's going up and over at the same time. So you guys really need to think about slope as how much I'm going up and over. Or he also could go down the hill, and so it could be down and over. But I really want you to, it's really the change from one place to another. Now, yesterday when we talked about it, I said the slope is the rate of change from one point to the next point on a line. But what I said was really important is that when we're talking about graphs, we always look at the graph from left to right. So if I'm looking at this graph, I know that from this point to this point, I'm going up 2 and to the right 3. Oops, and my pen doesn't want to work today. So let me get back to that. So if I look at it, I'm going up 2 and to the right 3. We also want to think of it as the rise over the run, as a fraction, as a ratio. Now why is that? Well, we've got two things happening at the same time. And notice I spelt rise with a Y. I didn't do that because my spelling's bad. I did that to help us realize when we rise, we're going up or down that Y-axis we've been talking about. And when we run, we're going left to right along the X-axis that we're talking about. So it's how far have we gone up or down versus how far have we gone left or right. Here we say that we've gone up 2, so we've risen 2, and we've gone to the right 3. So 2/3 would be my slope. Again, I keep switching. So 2/3 would be my slope. So 2/3 is the slope of the line. All right, let's talk about some more stuff here. Okay. There's two types of slopes that we can have when we're talking about lines. We can have a positive slope and a negative slope. But the most important thing is when we're looking at them, we're always going to look at the line from left to right. So if I'm looking at this slope, I can say that the line is increasing. So the slope is positive. So if I look at it from left to right, the line is rising. Okay, so let's write that. It's a rising line. Whereas this one, if I look at it from left to right, this is a falling line. So we would say the line is decreasing, so the slope is negative. Well, we still can calculate it the way that we calculate slope. So we calculate the rise over the run. Okay? So I want you to think when we go up, it's positive. When we go down, it's negative if we read the graph from left to right. So here, I'm just going to put a point right there on that line and maybe right here. Sorry. All right, so then we can say to ourselves, from this point to this point, how far have we risen? So we've gone up 2, so up 2, and to the right, 1, 2, 3. So we would write that, so to the right, 3. So our slope would be 2/3, okay? So when we go up and to the right, it's positive. Now looking at this one, let me get this out of the way. I'm going to go ahead and put a dot right there and right there. And I'm going to look between the 2 points, what's happening. Here I'm going down 1, 2, 3, 4. So down 4 and to the right 1, 2, 3, 4, 5. Okay, so there's that right 5. So We always want the right going to the left to right on the bottom, but the down indicates it's a negative slope, so I'm going down. So my slope is -4/5. We're going to do a lot of practice with this, so don't worry. But remember, up means positive, down means negative, as long as we're looking at it from left to right. All right, so let's talk about positive and negative slope. I want to make sure you understand it. So I really want you to use a red pen, and I'd like you to draw a line with a positive slope. So to do that, pick any 2 points, okay? And a positive slope, oops, sorry, it's negative slope. Positive slope would mean that I'm rising from left to right. And so go ahead and draw a line using that ruler I've asked you to use. Remember, if we're going to use a line, we have to have arrows at the end, otherwise it's a line segment. Okay, then we're going to use a blue pen to indicate a negative slope. Okay, so we want to see a negative slope, so that means it's falling from left to right. So pick any 2 points on the graph and connect them. And there is our negative slope. So again, this is a negative slope, this is a positive slope, and you're going to have to be able to look at something and tell me if it's a positive or a negative slope. All right, let's keep going. There's also a way for you guys to calculate the slope without a graph, and that's using the slope formula, okay? So again, here's another reason why I use rise over run, okay? Because the slope formula is the change in y over the change in x. I want you to write this. Okay, now I gave you the slope formula, but a couple things we need to know. M is the variable that we use for slope of a line, or slope, okay? So there's that M, so M equals. So this is saying slope equals y2 minus y1. Y2 and y1 are just the way for us to indicate different coordinate points for y. And x2 and x1 are just different coordinates for x. Again, a nice way to think about it is a change in y over a change in x. And the variable triangle in math, we're going to use it in formulas to indicate change. Okay, so I gave you the process. You're going to label an ordered pair with your y1, x1, x1, y1, x2, y2. You're going to label the other ordered pair. You're going to substitute the numbers into the formula, and then you're going to simplify. Well, let's go through that process. All right, so here we go. I wrote the formula for us. M, so slope, is the change in y over the change in x. I've got points right here. So how do I label them? Doesn't matter which one you pick as your point 1 or your point 2, but you have to label them the same. So if I said that this is x1, then this has to be y1. If I say this is x2, then this one has to be y2. Okay. Now, you could have labeled this one x1, y1. It doesn't really matter as long as you label them accordingly. Then you substitute them into the equation. Anytime we sub something in, we are going to put it in parentheses, and I'm going to be crazy about the parentheses right now, okay? So y2 is -1 minus 2 all over. x2 is 4 minus 0. Okay, now let's remember this point, kind of as a note, the point 0, 2. I'm going to plot them right here for myself, 0, 2. And the other point is 4, x is 4, y is -1, so right here. Okay, all right. This we have to remember is our y-intercept. When x is 0, that's going to give me my y-intercept. I'm going to simplify our equation. -1 minus 2 is going to give me -3. 4 minus 0 is going to give me 4. So my slope is a negative slope, so that tells me that the line is falling from left to right. Okay? Now I'm going to go over to the points I plotted. And I'm going to go ahead and draw a line in, put arrows at the end, make sure I get through those points as nicely as possible, so I'm using my ruler. Now, could I have done this without the slope formula if I had the graph? I absolutely could. I went down 1, 2, 3. Down 3 means -3. And then I went to the right 1, 2, 3, 4. And that's my rise over my run. So my slope, variable of m, would be -3/4. Should get the same answer. Means the same thing. All right, let's keep going. Now it's your turn. We're going to go ahead and try this. I'm going to do it as well, but you can press pause here and just check your answer at the end. Okay, so I'm going to label my points, x1, y1, x2, y2. I'm going to go ahead and substitute my values in. So y2, -4 minus 3, all over x2 is 1 minus -6. And there's a good place why I'm using these parentheses, because now I've got this negative to deal with. Then I simplify. -4 minus 3 is going to give me -7. 1 minus becomes plus, right? So we turn that to plus. So -7 over 7, which is -1. So my slope is -1. All right, so I'm going to plot my points. -6, +3 right here, and 1, -4. Okay, and then I'm going to go ahead and draw my line. Okay, now, a couple of things that you can think about. Yes, you can go from point to point, but you can also find other points. Like I could plot this point right here if I wanted to, if I was doing the rise over the run from the graph, as long as it's going through an actual coordinate point. And so I'm going down 1, 2, 3. So down means negative, and to the right 1, 2, 3. So no matter what, as I've got 2 points on the line, I should be able to calculate the slope, which would give me -1. All right, a couple more things. Some really important slopes that we need to consider. We've talked about these 2 lines, and I want to make sure that you feel comfortable with them. This is a horizontal line, okay? There's that horizontal line, and if that is look at that, if that's not really rising as far as it's going, it's not rising or running any different amount. We say that this has a slope of 0 because it's not really rising over its run. This one, we'd say, this vertical line, we would say it has an undefined slope. It's not really a slope. You can't ski on it. Could we ski on this? Yes, we could ski on a flat surface. It's called cross-country skiing. But here, if we were trying to ski on this, what would be happening? We'd be flailing our arms and falling. This is like falling off the cliff, okay? We're jumping off a cliff here. So it has an undefined slope. We could also say no slope. Okay? All right. So if we see a horizontal line, first of all, if we calculate the slope, we are going to get 0. How do we get 0 with the slope? That would give me a 0 in the numerator. As a reminder, we should remember that the equation of a horizontal line is y equals the y-intercept, which in this case is 1, 2, 3. So y equals 3. Vertical line, how are we going to get an undefined slope? We would get an undefined slope if we have 0 in the denominator. Remember, 0 under means it's undefined. So we would know that it's a no slope or an undefined slope, so we'd know it's a vertical line. Vertical line's equation, again, is x equals the x-intercept, which in this case is 3. All right, keep going, we're almost finished. So let's look at what happens when we calculate this slope. We label our points x1, y1, x2, y2. All right, we plug in, we substitute our values in. We always, when we sub in, we put them in parentheses. So 5 minus 5, all over 4 minus -2. 5 minus 5 gives me 0. 4 minus -2 gives me 6. 0's in the numerator, which just means 0. So the slope is 0. So now I have to recognize this means it's a horizontal line, and it's y equals the y-intercept. Okay, well, how do we get the y-intercept? First of all, you might notice that the y's here are exactly the same. So it works out to be y equals 5, but let's talk about that. -2, 5, and 4, 5. If I connect those and draw a line through it, well, yeah, my y-intercept would be 5. So if the y-coordinates are exactly the same, if we subtract the same coordinate from the same coordinate, we're going to always get 0. So that number will always be my y-intercept, so y equals 5. Okay, now we're going to stop there, and we are going to talk about this more tomorrow. So I'm going to follow up and kind of review everything, and then we're going to practice in class. What I'd like you to do is I'd like you to try this next one and bring it in for me and see what happens. And as a challenge, so -1, 4, -1, -3, I'd like you to calculate the slope, plot the points, and then see what kind of line you've created, okay? All right, guys, great job on slope today, and I will see you tomorrow. Bye.